Here I'm going to show you how to take a measurement, sectioning and measurements basically. So now I want to take the measurements of the door to the rear panel body. It's important to also note that when you're taking the sectioning, it's going to either export it in polylines or as a curvature. You need to be sure of which of them you want to use because um, depending on which you export it as, you will be able to measure it easily or you have a lot of dots. So go to tools, and in tools we go to digital mockup and go to DMU section, which is digital mockup sectioning, and scroll down to the bottom. And if you select use curves instead of polylines for export, then you have a full curve and you can take your measurements easily. If you use polylines, you have a lot of dots and discontinuity, which makes it more difficult to take your measurements. Alright, so we make sure this is selected, use curves instead of polylines, and click OK. Once that is done, you might want to change to digital mockup, um, digital mockup space analysis. Once we've changed to that, you notice that the icons on your right hand side change. You can go here directly to sectioning. In sectioning, it brings out these two windows. This shows the exact section where your plane is at. To help with visualization, we can make both of them tiled vertically, so we have both of them in half. Alright, we can reduce the size of this, and now because we want to measure the tolerance between the door panel and this, it's best if we take our positioning from the z-axis. Okay, as it is here, you see it clearly here, which means if you zoom in, you can see the discontinuity right here, which is the clearance between the door panel and the rear panel. Okay, so now that we have that, you can choose different methods. You can set the geometrical target, which means you can easily just do this as well. It gives you the same thing anyway. You can do this. Um, you can also position by 2 to 3 sections. This selects 2 lines that you want around the car, and you basically just sections around the 2 or 3 lines that you've picked. You can edit the position if you have um, the measurements already, and you just use that. Well, yeah, let's go with this. We've selected the geometrical target, which is that. And now what we're going to do is we are going to go to results, and we're going to export and open the results. We can also export and open in this existing part, but just to help make it a lot clearer, we'll export and open it in the new windows. Okay, I'm gonna click that. I'm gonna export it as a part, not a drawing, because if you choose a drawing, it comes out in drafting. Okay, so choose this. Wait. Okay, so now it's open the part. I don't like to use these planes, so I usually hide them and choose an axis plane. But before that, let's fit all in so you can see your drawing. Your part is here now. And what I like to do is insert my axis, and I choose this as the center and click OK. Alright, so now you have your geometrical set and they are all in curves. When you check, you can see you have fully continuous curves. If this was in polylines, um, you have a lot of dots instead of full curvatures. Alright, so we can easily take measurements now. Um, So make sure this usually is on any geometry. Go to points only for the first one and the second one. Okay. So we can easily select this, select this. And we see that the distance between both of them is 5.617 millimeters. Okay. However, say you want to measure, a radius, and you come here, you try to measure a radius. All right. Let's see. This is the curvature. Let's see if we can easily measure the radius. Okay. Come back here. Oh, that's still on point only. So let's go to any geometry, measure item. To measure this, it gives us the distance or the length of the arc. This is not giving us the radius, and we want to know the radius. Okay, so what we can do is quite simple. We can project the plane. Alright, so let's make it 1000 as this is full scale. Reverse direction. Okay, that's right here. Okay, so we're going to sketch on this new plane in our sketch, all we're going to do is select this section already, and we are going to project 3D elements onto the new plane. Okay, it's going to take a while because there are a lot of lines. Okay, once you set the element resulting from the projection onto each plane as associative, the number of non-associative elements is okay. So once that is done, because this is what basically helps us to be able to measure the radius. Okay, so now we've hidden everything, and we can come to our sketch. Right, so now when in sketch we can select the top plane, right? So to do that we can use a 3-point arc, measure from one point to the next. Right, remember. And because the arc is coincident to this other arc, we can see that the radius is 30.053. Right, so that's a simple way to measure your arcs as well. Alright, that's what I just wanted to show. So we've been able to measure the distance first of all, and we've also been able to measure the arc at this point. So this is quite important for taking accurate measurements and ensuring that parts meet the parts and quality specification. And yeah, that's what I wanted to show you all. Thank you.